Okay, welcome to our last little segment on interpreting research results. And in this last bit, we're going to talk about inferences. Okay, you've got some data. How much confidence can you have in your data? How comfortable are you using your data and the conclusions that you draw from your data to make inferences, to extend the data to other people and other situations? This is a big question. Can you, for example, use your results to predict how people in other parts of the world will behave? I'll give you an example of research, rigorous research, that is limited in its ability in its inferential ability. Okay. We know that in a woman's lifetime, her odds of getting breast cancer are 1 in 8 or 1 in 9. Now, men get breast cancer too, but it's much less likely. 1 out of 1,000 men will get breast cancer when 1 out of 8 women will. Weirdly, the National Institutes of Health for years conducted nearly all of their research on breast cancer in men. Really, the idea was, well, men don't have as much hormonal variation, so if we understand it in men, we'll be able to explain breast cancer in women. Well, breast cancer in men and breast cancer in women, it's not at all obvious that you can generalize from one to the other, given the differences, the likelihood differences in getting breast cancer. So there's a bias here, right? The data collected from breast cancer studies in men weren't actually really helpful in coming up with treatments or expanding our understanding of breast cancer in women. So when can you trust your data? Well, you can have more faith in your data if the sample that you're studying, the people or the situation that you're studying, is representative, is a good example, is an unbiased example of the sorts of people that you want to make inferences about. So, for example, several lectures ago, I used the example of, say, you want to find out how often people in the U.S. text on their cell phone, and so you go to the nursing home next door and do your studies there. Your conclusions could be beautiful. However, your sample wasn't representative. It was an unusual sample. You're only studying people in nursing homes. So it's unlikely that you'll be able to generalize or extend your research results from a nursing home to, say, kids in high school, right? So picking good populations, good samples from populations, representative samples from populations, that's really important in your ability to trust your data. Another factor that's very important is that if you only have a few measurements, if you've only tested a few people, you better be really careful with your data. You can't have a whole lot of confidence in your data. If you run a really big study and you have lots of measurements, you can be a lot more confident in your data than if you have only collected a few measurements. And I'm going to use the example here of M&Ms. So when M&Ms are made, there is a certain percentage of them that are red and a certain percentage that are brown and a certain percentage that are yellow. This is the reality of the situation. So when M&Ms are produced, 13% of them are red and 24% of them are blue. So if you allow me to fudge a little bit, I'm going to say there's twice as many blue M&Ms as red M&Ms. Now, if you're in the U.S. and of a certain age, you may have gone to trick-or-treating or Halloween parties and received those little packages of M&Ms that contain maybe, 10, 12 M&Ms in them. If you open one package of M&Ms, those little packages of M&Ms, and count whether there are twice as many blue M&Ms than red M&Ms, or even whether there are just more blue M&Ms than red M&Ms, you don't have a lot of data. Not every little packet of M&Ms is going to have the percentage a greater percentage of blue than red, right? But if you take a big bowl and you open up, say, 10 of those little packages of M&Ms and throw them in a bowl and then count them, you are much more likely to find more blue M&Ms than red M&Ms. As the number of measurements increases, your confidence in your data increases as well. So why is this important in an introduction to psychology class? Well, have you ever had the experience where you're talking to someone about a very common phenomenon, and their response is, well, I've never seen that. Okay, there's the problem. They are taking one measurement, right? Their own lives. We put a lot of weight in our own personal experiences. However, our own personal experiences are not a whole lot of data. If you take the experiences, the average experiences, for example, or the modal experiences of a community or a city or a state or a country, you're going to have much more confidence in those measures than in your measurements from any one person. So, for example, you might know, well, let's go back to breast cancer. You might know someone who has breast cancer, and there are scientific treatments that have been tested rigorously with experimental designs that show that particular medical treatments help people with breast cancer. But you might know one person who never got any treatment for their breast cancer and they turned out to be fine. Or one person who decided they were going to eat tons of bananas, or I don't know, tons of cantaloupe or tons of avocados, and their breast cancer didn't grow. Those are individual cases, not very reliable. It's hard to make inferences from them. So even though you might have a friend that insists they know of one person who cured their cancer with avocados, the odds of that result generalizing to others is pretty small. Okay, that's it for our interpretation of research methods. Everybody in my intro psych class, time to go back to Canvas, study, do the lab, and then come back for the quizzes. Okay, bye-bye.